Welcome everybody. Our today's topic is personalization using comparison data. We have come quite far in learning about recommendation or personalization. Starting from the simplest personalization algorithm that utilized population level information, in the last few chunks, we have discussed various ways to develop highly personalized recommendation algorithms. The algorithms we discussed were primarily doing matrix completion. I suggest you do check the part of this module on rank centrality again, especially if you want to remind yourself how to calculate the chance of sun not rising tomorrow. Now coming to the question of interest for the day. We shall discuss this question again in the context of Netflix. There are a collection of users and movies. Each user expresses preferences over movies in the form of pairwise comparisons. Imagine Netflix showing that user a pair of movies and asking user which of these two movies did she like more. Of course, Netflix already has such data, as a user might have rated few movies already, and the rating of movies implicitly provides comparison between the rated movies. For example, if I rated movie Casablanca 5 and One Flew Over the Cuckoo's Nest 4, then I am suggesting that I like Casablanca over One Flew Over the Cuckoo's Nest. Okay, so for each user, we know that she has expressed preferences in form of comparisons between a few pair of movies. From this data, for each user, we want to figure out the ranking over all the movies for which she has not provided any preferences or ranking. In the setting of matrix completion, we wanted to predict unknown ratings. Here, we want to predict the order or ranking between all the movies for which we have no preference data for each user. So clearly this seems like a much taller order than just matrix completion. I want to convince you that that is not really any different from matrix completion. It is almost like matrix completion with few twists and turns. First, let us transform our data in matrix form. As before, in our matrix, we have rows that correspond to users. Each column does not correspond to movies anymore. Instead, each column corresponds to an ordered pair of movies. For example, consider an entry. Let us suppose its row corresponds to me as a user and its column corresponds to a pair of movies, Casablanca over One Flew Over the Cuckoo's Nest. Therefore, if there are n movies in total, in principle we have n multiplied by n minus 1 divided by 2 columns. For n equals to 3, this will turn out to be 3. For n equals to 10, this will be 45, and so on. Now each entry in the matrix is either plus 1 or minus 1. Of course, if it is missing, then we do not know what it is, but it will always be either plus 1 or minus 1. For example, if entry for row corresponding to me as a user and column corresponding to Casablanca over One Flew Over the Cuckoo's Nest is equal to plus 1, then it means that I like Casablanca over One Flew Over the Cuckoo's Nest. And minus 1 means that I like One Flew Over the Cuckoo's Nest over Casablanca. Therefore, for each user, we will have a row with some plus 1s and some minus 1 entries. Remaining of the row will be blanks, that is unknown values. Ideally, we want to predict plus 1 or minus 1 for each of the blank entry, so that it leads to ordering of movies for which user has not expressed preferences. For example, if for movie Iron Man and Superman, I have not provided preferences, that is the entry corresponding to column, Iron Man compared to Superman is unknown, we want to predict it to be plus 1 or minus 1. As we shall see, we may end up predicting it to be a number between plus 1 and minus 1 rather than a number equals to plus 1 or minus 1. And from this, we would like to produce ranking over all movies with unknown preferences. Again, in the example above, if there were only 2 movies, say Iron Man and Superman, with unknown preferences, we are really trying to figure out whether Iron Man is preferred over Superman or the other way around. And this is easy because we can look at the predicted value which will be between -1 and 1. If it is greater than 0, we shall say Superman is preferred over Iron Man. If it's less than 0, then we shall say Iron Man is preferred over Superman. And that's it. The question is, what happens when we have more than 2 movies? In a nutshell, we have 2 challenges. 1. How to predict this value between -1 and 1 for each pair of movies. 2. Given these predicted values, how to compute ordering or ranking between all the movies with unknown preferences. Short, for 1, we will use the matrix completion algorithm like collaborative filtering, and for 2, we will use rank centrality. Nice, right? No extra work today. We will use what we have already learned. I love when this happens, and today is that day.